Okay. Today, we still consider the computation of this integral. The basic idea is use interpolation polynomial to approximate the function f. Then this integral is approximated by the integral on the interpolation polynomial. From the interval AB, we pick some points, n+1 points, and we assume these points are different. Then the Newton interpolation polynomial at these points is given by this equation. This is a Newton interpolation polynomial, where Q is given here. And the error term is given by this expression where psi x is between A and B. Now take integral. I call this equation 1. Take integral on the both sides. P here. P roughly is f. Now take integral. Because I have error term, so should be equal sign. Yeah, equal. Now take integral on the both sides of this equation. Then we have this equation. Drop the error term. We have a quadrature formula to compute this integral. Okay, now in the last class, we learned trapezoid rule. Trapezoid rule is a special case. In trapezoid rule, we said n is 1. That means that we choose two roots, x0 and x1, and set x0 to be a, the left endpoint of the interval AB, and x1 to be the right endpoint of the interval. Then n is 1. That means that we pick the first two terms in this equation. Compute the divided difference for these special roots. Then we have trapezoid rule. And the error term of trapezoid rule is this. This is a special case. Now today we study a second special case. Number 2. We said n is 2. We pick 3 roots. And x0 is a. x1 is the midpoint of the interval AB. A plus b over 2. And x2, the right endpoint of the interval AB. Right. This time, we use 3 terms in this equation. 3 terms. Now for the special choice of x0, x1, x2, we compute the divided difference and also compute these 3 integrals. Then we get a quadrature rule. We call that quadrature rule Simpson's rule. Okay. Then we have Then we have Simpson's rule. Okay, yeah, Simpson's rule. Yeah. Integral AB f dx roughly is b minus a over 6. Simpson's rule. For the error term of Simpson's rule, we compute, let me see, we compute error term. Error is equal to integral. Now n is 2. Yeah, this is the error term. Error term n is 2. So integral a to b e to x dx. By the formula for E2, the formula for E2 is 1 over n plus 1. Now n is 2, so 1 over 3 factorial. The derivative on f evaluate at some point psi. This point depends on x. And let me see, what is En? En is here. Then times this product. This product is x minus x0 times x minus 1 times x minus 2. Yeah. So this is x minus x0, x minus x1, x minus x2 dx. X0, x1, x2 is defined here. Okay, now let me compute this this integral. Let me make a change of variable. First, I let h be the distance between the adjacent points. The distance from x to x1 is h. x1 to x2 also h. H is b minus a over 2. Let h be b minus a over 2. And make a change on the variable x. Let x be x0. x0 is a plus t times h. Now, with this new variable t, this integral becomes integral from 0 to 2, 1 over 3 factorial. Sine depends on x. Now x depends on t, so depends on t. Then x minus x0. X minus x0, move x0 to the left side. So x minus x0 is th. So times th. And then x minus x1, I plug in this equation in x. Then the second factor is x0 plus th minus x1. The next factor is x minus x2. So x0 plus th minus x2. Dx is t times is h times dt. This is h times dt. Now let me simplify. 0 to 2, 1 over 3 factorial, the derivative psi at t, t times h. X0 minus x1 is negative h. So we have t times h minus h. X0 minus x2 is negative 2h. Negative 2h. And then times h times dt. Now, h is a constant. I take out h from the integral and also move this number 1 over 3 factorial outside the integral. How many h we have? 1h, 2h, 3h, 4h. So h to the fourth over 6, right? 3 factorial is 6. And then integral 0 to 2. F the derivative psi t. And then here h is out, so t minus 1. T minus 2. Then dt. This is a number. It is a number. Say, let me denote the number by c. So we have c over 6 times h to the 4th. We call that h is b minus a over 2. That is h, right? Yeah, h. b minus a over 2. B minus a over 2. 4. So we have c times 6 times 2 to the 4th. B minus a to the 4th. Yeah, this is the error term for Simpson's rule. Yeah. When I add the error here, then the approximation becomes an equation. Okay. But this error term, the power is 4. So Simpson's rule is an order 4 formula. But it turns out that for this special choice for the roots, Simpson's rule, the error term actually is order 5 instead of order 4. Why? Because we noticed that in this approximation, the right side, integral, but the next integral, a to b, q3 x dx, the next integral in the 4th term, first term, second term, third term, then the last term is about this integral. But it turns out that this integral, AB, what is Q3? X minus X0. X0 is A. X minus X1. X1 is the midpoint of the interval AB. And then X minus X2. X2 is the right endpoint B. This is a Q3. For this special choice for the roots, it turns out that this integral is 0. How to see this? I will show you. Okay, the 4th term, it turns out that is 0. So actually, we can compute the error by interpolation polynomial at these 4 roots rather than at only 3 roots. Okay, Then if I use four logs, then I will have an error term. The error term, the new error term, the power here is 5, not 4. Okay, so the error actually is improved. Okay, now let me. Okay, now take x0 in order for improving this error. Let x0 be a x1 midpoint, x2 right endpoint. Now x3 arbitrary. Okay, arbitrary. Yeah, but of course I assume x3 different from x0, x1, and x2. Now temporarily at this point x3 an arbitrary point between A and B, Right. Then if I use 4 points, then from this approximation I have, then we have integral AB let me add error term. So equal to f x0 divided difference of order 0 integral AB Q0 and then plus x0 x1 AB Q1 plus f x0 x1 x2 AB Q2 dx. Now I use 4 loops. So one more term is f x0 x1 x2 x3 integral on Q3 dx. Now plus error. Error is integral. Let me see. Error. Yeah, error here. N is free. So N is free. So integral on E3. Integral on E3 x dx. Okay, now I compare divided difference and compare integrals. Then the first 3 terms is Simpson's rule is B over 6 FA plus 4 FA plus B over 2 plus F of B. Yeah. Compute the divided differences and the integrals in the first 3 terms, then simplify the result. We get this. This is the Simpson's rule. Then plus the 4th term, f x0 x1 x2 x3 integral AB q free plus integral on E free x dx. Now I claim that this integral is 0. Okay. Okay. To see this integral, is a b x minus x0 x minus x1 x minus x2 doesn't involve x3. X3 arbitrary. Okay. This is 0. How to see this integral is 0? Let me make change on variable. Okay. I said x is t plus the midpoint. X1 is the midpoint. Yeah. AB. This point x0. The midpoint x1. This point x2. How about x3? Arbitrary pick. X3. Arbitrary pick. Okay. Now this integral is 0. How to see it? Make a change on variable. Then the integral is equal to when x is a, t is a minus x1. When x is b, t is b minus x1. And then plug in this equation in x, so t plus x1 minus x0. And x minus x1 is t plus x1 minus x2. Then dx is equal to dt. Okay. All right. x1 is midpoint. A plus b over 2. Therefore, a minus x1 is negative b minus a over 2. B minus x1 is b minus a over 2. And midpoint minus x0. X0 is a. So it is x1 minus x0 is b minus a over 2 times t. X1, the midpoint, minus x2. X2 is b. T minus b minus a over 2 dt. Okay, now t plus this number times t minus the same number is equal to t squared negative b minus a over 2 b minus a over 2. Yeah. This factor times this factor is t squared minus b minus a over 2 squared. Then times the middle factor t dt. Yeah. And over the interval from this number to this number, this function is a off function. What is off function? Off function is f of negative t is equal to negative f of t. The graph of an off function is symmetric about the origin. Okay. This function is an odd function, and the integration interval, integration interval is from negative p minus a over 2 b minus a 2. This interval also symmetric about the origin, right? Also symmetric about the origin. All function integration interval symmetric about the origin. So this integral must be 0 from calculus 1, must be 0. So therefore, this term is equal to 0. Now I can drop this term to get the following equation. Integral AB f of x is equal to this number plus 0 plus the error. So it is b minus a over 2 over 6 over 6 f a plus 4 f b minus a b plus a the midpoint f b, then plus the fourth term is 0, so plus error term is E3. Okay, now let me compare the error term. Okay, where the error term is E3. Let me go back to the formula for En. What is En? Oh, En is given here. En. Now n is 3. So this is a 1 over n plus 1. N is 3. So 4 factorial f derivative on f 4 times. Evaluate a sign. Sign depends on x and also depends on x3. X3 I arbitrarily pick. X3, and then times x minus x0, x minus x1, x minus x2, x minus x3 dx. This is the error. Now let me compute the integral. Okay, let me compute the integral. Okay, because x3 is arbitrary. Now I let x3 approaches x1. X1 is the midpoint of the interval AB. Okay, then we have error is equal to AB actually integral from A to B on E3. This is a constant because take a look at this equation. This integral is a constant, and also this term, a constant, doesn't depend on x3. So therefore, this integral, a constant, doesn't depend on x3. Now take limit on the both sides. Then we get, okay, x3 now get closer and closer to x1. So sine only depends on x. Okay, and also depends on x1, but x1 is a constant midpoint, so only depends on x. X minus x1, x minus x2. Now x3 approaches x1, take limit. Okay. Then therefore we have 4x. Combine this factor and this factor. X minus x0, x minus x1 square, x minus x2 dx. Okay. Hey, notice that this function x minus x0 is A, x minus x2 is B, x1 is midpoint. Yeah, this function always negative, non-positive on the interval AB. This function, you see, arbitrarily pick an x, then x minus x0 positive. The middle factor always positive. And x minus x2 is B, so negative. So this function non-positive. This function non-positive everywhere over this interval. So by mean value theorem for integrals, I can move this function outside the interval. Okay, now we have 1 over integral AB E3 x dx 1 over 4 factorial derivative on f 4 times. Evaluate x some new sign. Okay, this new sign doesn't depend on x. Then integral x minus x0, x minus x1 square, x minus x2 dx. Okay, where recall that x0 is A, x1 is midpoint, x2 is B. So this integral is computable. Okay, now compute this integral. We have sine is in AB. Sine x is in sine x x3. Yeah, here. This is in the open interval AB. But when I take limit, this sign, it is likely possible to be one of the endpoints. So for safety, I claim that sign is in this closed interval rather in open interval. Yeah, this guy is open interval, but take limit. The sign, sine x. Yeah, actually sine x. Yeah, this is in closed interval because the limit. Limit. Yeah. Say for example, 1 over n greater than 0. But when you take limit, n approaches infinity, then we have equal sign. So, yeah. Okay. I compare this integral, then I get the error is equal to compute the integral, then combine with 1 over 4 factorial. Then I get this. 4 derivative sine over 2a0, then times b minus a. Now this time the power is 5. Is 5. So actually, Simpson's rule. Simpson's rule. Yeah, Simpson's rule. The order is 5. Better than not just 4. Okay, not just 4. Yeah, because of the observation that the fourth term here is 0. So we can use the observation to get a better error term. So yeah. So therefore, let me make some summary. Simpson's rule. Simpson's rule. Okay. This integral can be approximated by b minus a over 6 f of a plus f a plus b midpoint and f b. Okay. The error is negative f 4 2a0 b minus a to the fifth. Okay. One problem with Simpson's rule. Okay. The problem is when the interval AB is large, that is B minus A is large. Okay. When B minus A is large, B minus A to the fifth is large. So the error, when the interval is large, the error can be very large. Then how to solve this problem? Cut the interval AB into subintervals. Each subinterval, the length less than 1. Then in this way, we obtain composite Simpson's rule. Okay. And composite Simpson's rule. In order to keep the error small. Okay. Simpson's rule. Okay. Partition the interval AB into subintervals, and each subinterval the length less than 1. Okay. Okay. With the partition points be x0 is A, then less than x1, less than x2, less than x3, and so on. Less than xn. The last point xn is B. Yeah. Let me draw a diagram. A, B. This is x0, x1, x2, x3, x4, x5, and so on, and so on, and so on. Then apply Simpson's rule. Simpson's rule involve 3 points, right? Simpson's rule, yeah. 1 point, 2 point, 3 points. So apply Simpson's rule to this interval, and apply Simpson's rule to this interval. and to this interval. So therefore, here n should be an even number, not an odd number, even integer. Okay, even integer. All right, now then after I cut the interval AB into subintervals, I can write the integral. Then the integral AB can be split into a sum of integrals. The first integral, x0 to x2. Second integral is x2 to x4. And so on. The last interval, suppose B is xn. The last interval is xn minus 2 to xn. And then apply Simpson's rule to each integral. Roughly, we have the first integral. Simpson's rule is here. Let me further assume these points, the partition points, evenly spaced, the partition point evenly spaced, with the space size, the distance between two adjacent partition points is B minus A over N. N is an even number. Okay. So let me write this sum in sigma notation. Sigma notation is I from 1 to N over 2. N is an even number. Integral x 2i minus 2, right? When I is 1, 2i minus 2 is 0, x0. To 2i. When I is 1, 2i is 2. So I is 1. This integral is the first integral. When I is 2, 2i minus 2 is 2. 2i is 4. So when I is 2, this integral is the second integral. Okay, now let me write this sum in sigma notation. Okay, now apply Simpson's rule to this integral. We have Simpson's rule. B minus A. For this integral, B is x2i. A is x2i minus 2. So B minus A should be 2h constant. I move it out over 6. Then summation I from 1 to n over 2. F of A. A now is this point. So F x2i minus 2 plus the middle term is 4 times F x2i. The midpoint from this point to this point is 2i minus 1. Yeah, 2i minus 1. The midpoint. Yeah, let me erase here. and then plus f at b. B now is x to I. X to I. Okay, now simplify the sum. Then we have low error term here. Okay, these are approximation, correct. Okay, simplify the sum. Then we have h over 3 summation, log summation. Times x0 plus 2 summation I from 2 to n over 2 f at 2I minus 2 plus 4 times summation I from 1 to n minus 2 f at 2I now log minus 2 but minus 1 and then plus f xn. Expand this sum and rearrange terms. Then we have this equation. Yeah, this is a composite Simpson's rule. Then how about the error? Okay, let me determine the error. The error is error of the composite Simpson's rule. Summation I from 1 to n minus 2 a negative. Yeah. Error term. Yeah, there is a negative. And f fourth psi I. Psi I is this guy is in the interval 2I minus 2 x 2I. 2I. And then 2A0 times b minus a, the length of interval. Okay, yeah, for each integral, the interval, the length is from this point to this point is 2h. Therefore, times 2h to the fifth. Now, let me move to this is apply the power to 2 and to h. Then move h out. H to the fifth over 2 to the fifth divided by 2a0. It is a 90 summation I from 1 to n minus 2 f psi I. Okay, now the sum, let me take average on the sum. Recall that what is h? H is 90 b minus a over n. Okay, then the sum, there are n over 2, so many terms. Okay, let me further. Okay, b minus a over 2 times 1 over n over 2. Psi I. Okay, now this is an average of the fourth order derivatives. So this I can choose. There is a sum point sign. This sign is in AB, this closed interval. Okay, such that this average is equal to this. So I can simplify. the error, order 4 times b minus a times f4 derivative evaluate at some point psi. Psi is in this closed interval. Yeah, this is the error for composite Simpson's rule. So composite Simpson's rule is an order 4 quadrature formula. Yeah, order 4. Yeah, order 4 quadrature formula. This is all for today's class. Let me stop here.